Start record. Okay, so today we are going to study chapter 1, Introduction to Statistics. And this is our textbook. You can see, you can find it online, or you can buy the hard copy. Let's get started with the first three sections. The first section, statistical and critical thinking, types of data and collecting sample data. So what is statistical and critical thinking? Maybe I'm gonna, okay. Can you see it from the back? Yes, right? It's clear, right? Okay, the key concept here. Actually, statistical thinking involves critical thinking and the ability to make sense of results. Statistical thinking demands so much more than the ability to execute complicated calculation. Maybe when you read this concept, what do you think about? Maybe we can think about an example for the critical thinking. Maybe if you think about the best treatment plan, right? For example, if a doctor is presented with a patient experience in maybe a headache, and then we can ask the question first, right? After that, we will consider some alternatives, maybe reasons about the headache, and evaluate those evidence. Also, we can the next step is we can think about all the assumptions, and we can make the reasoned decision. So that is critical thinking in the real life application. And the process involved in conducting a statistical study consists of prepare, analyze, and conclude. That is the terminology that we need to take into account here for statistical thinking. And the second thing, that is the data. Collections of observations, such as measurements, changes, or survey responses. Maybe we can, for this data, we have a lot of examples in the real life. For example, if we collect maybe votes, right, from all the people, for all the citizens, then that is collecting data as well. And we can give some examples about statistics here. The science of planning studies and experiments, obtaining data, and organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusion based on them. What can be an example for statistics in the real life? For example, to understand whether college students get enough sleep during maybe the exam time, exam week, right? We can plan, and for the statistics here, that is the goal, and we have to collect data. That is the first thing. The second thing, we need to organizing and summarizing the data. That means we calculate the average number of hours that we sleep. That's the students sleep during that week, and we analyzing those data, right? And we draw the conclusion. So that is statistics. And for population, so what about population? The complete collection of all measurements or data that are being considered. Typically, a population is the complete collection of data that we would like to make inferences about. So what do you think about population? Population. If maybe if I give you an example, a school, let's say a national university, wants to know the average number of hours students sleep per night, then the population here, we can consider all, let's assume maybe 2,000 students enrolled at this school, right? So the population here is 2,000, all 2,000 students at National University. Are we good, everyone? Yeah, so no questions so far? Yeah, okay. Census versus sample. So these are two new definitions, right? Census, the collection of data from every member of a population. The collection of data from every member of a population. So what can be the census here? What do you think? Any ideas? Yeah. Oh, the survey. Yeah.
Yeah, like of the general population, like when we vote on a specific
Mm-hmm.
thing.
Yes. So when the government conducts like the national surveys about the votes, right? We are collecting data from every person living in the country. Not every person, but every citizen living in the country. So that is a census. Agree with you. What's your name?
Chelsea?
Chelsea. Yeah, thank you, Chelsea. Because I try to learn all the names, so maybe please give me some time to memory. Yeah, thank you. Sample, a sub collection of members selected from a population. This one I think is easier. For example, maybe we did it earlier. We wanted to know like the average number of hours that the students at National University sleep during the exam week. But here if we want to find the sample, maybe just we collect the data from a sample that is a sub collection of a big um, population. Then we will consider like maybe the average number of hours that student in our class sleep during that exam week. So that's gonna be a sub collection, right, of the population. So it's called the sample. Does that make sense, everyone? Easy, right? So easy for you. I should tell them to increase the level of difficulty for the exam. Watch what you post online. Example, in a survey of 410 human resources professionals, 148 of them said that job candidates were disqualified because of information found on social media postings based on data from the Society for Human Resource Management. Okay, so for this example, maybe I'm not gonna show the solution yet. Let's find what is the population, what is the sample in this one. You think population is 410? Are you sure?
Wouldn't the population be all human resource professionals and the sample be 410 of the entire population?
So we have two answers here, right? Who agreed with Jeremy? Jeremy said that the population is going to be 410 human resource professional who were surveyed, right? So we have 1, 2, 3, 4, 5, 6, 7. And who agreed with Maori? Maori. Maori said population will be all human resource professionals and sample will be the 410 human resource professionals who were surveyed. Okay, so the correct answer is Maurice's answer. Why? Let me explain. In this case, let's look at this one. In a survey of 410 human resource professionals, 148 is tricky, right? Of them said that job candidates were disqualified because of blah blah blah. But the thing is, let's see, the objective is to use the sample as a basics for drawing a conclusion about the population of all human resource professionals, right? And the methods of statistics are having to draw in such conclusions. So in this case, the population should be all human resource professionals. And when we sample it, we just like take 410 human resource professionals. And the answer like 148 here, it's just like, okay, okay, we got the result, like out of 410 we have 148 of them set that that blah 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 thing idea, right? So we, if I give you another similar example, maybe let's do this one in a survey of 10 students, or no, 500 students in our class. 10 of them said that math is very boring, and so in this case, population will be all students in our class, right? The sample here, what do you think? It's population and the sample in this case. So the population here should be all students studying. I'm gonna maybe if I make sure that I mention the maybe the in that sentence I would say all students studying mathematics and something like that, right? So it's gonna be more specific, and we can mention like population will be all students study mathematics, and then sample will be like students in our class. Are we good, everyone? Okay, so I'm gonna move to the next one. Statistical and critical thinking. I'm gonna zoom in a little bit. Can you see it from the back, Chelsea? No, right? Okay, because this slide is a little bit weird. It's very small. For the statistical and critical thinking, any question, Brian?
You just gonna look, I was trying to figure out where the PowerPoint presentation was.
Oh, okay. It's in the module 1. Yes. What do the data represent? What is the goal of study? Source of data. So this is like 3 steps for preparing. I'm gonna so if you want to know, let us focus here. I can show you later. It's fine. It's gonna be in the module 1, and then we can find the slide there. You can download it. Source of the data are the data from a source with a special interest, so that there is pressure to obtain results that are favorable to the source. And we the next step is sampling method. So that is the preparation and analyzing. We graph the data, explore the data. So for graphing, we have a lot of ways, right? Columns or something like circles, and then we have all the curve as well. Explore the data. Are there any outliers? Okay, statistics and probability, you will need to study this one later. Are there any outliers? That means numbers very far away from almost all of the other data. Like for example, this is one of the case, right? All this number is far away from almost all of the other data, because other data is like kind of zero, right? And all this data is far away. So it's there is one outlier here. What important statistics summarize the data, such as mean and standard deviation? We'll study that one as well. How are the data distributed? Okay, we have several types of distribution. Normal distribution or some other types we study it later. Are there missing data, or did many selected subjects refuse to respond? And we apply statistical method to obtain the results after analyzing the data. And then we make the conclusion. So for the third step, making conclusion, we will study some significance, like do the results have statistical significance, or do the results have practical significance? So these are all the concepts that we will study in this chapter. Okay, so let's get started with the first step, preparation, right? Shoe print length and height of 8 males. 8 males. In this case, we have prints in centimeters, height in centimeters as well. Context: the table includes shoe print length and height of 8 males. Let's see. In this case, we need to measure the shoe print length. Okay. and other crime scenes in order to estimate the height of the criminal. Let's see. In this case, the format of the table suggests the following goal. Determine whether there is a relationship between shoe print length and height of males. It's a very useful application for police, right? This goal suggests a reasonable hypothesis. Males with larger shoe print length tend to be taller. We are using data for males only because 84% of burglaries are committed by males. 84% of burglaries are committed by males. This is like discrimination, huh? This is just like some data. Just kidding, okay? Well, they summarize data, analyzing data, and make the conclusion. Prepare. Okay, so this is the preparation. Now, the source of the data. The data in the table are from data set 9, foot and height, in appendix B, where the source is identified. The source certainly appears to be reputable. Sampling method. The individuals were randomly selected, so the sampling method appears to be sound. In this case, we have 3 steps. The first thing we follow in the context. The second thing, we follow the source of the data. We know the source of the data already. The third thing, we need to use sample method, and in this case, because they do it randomly, so that's why it works. In this case, we can use the data from the sample, and then we can derive that result to make the conclusion for the population. Voluntary response sample. Voluntary response sample or self-selected sample is one in which the respondents themselves decide whether to be included. Okay, so in this case, can you give me an example for the voluntary response sample?
Feedback surveys.
Yeah. Moreover, if you give an example related to maybe the previous sample here, right? For example, we already have the main sample, but the thing is, we can ask like some other people who are volunteer to do that. We can add that to like as a side of the main sample, so it's called the voluntary sample. Yeah, that's I agree with Maury as well. The following types of polls are common examples of voluntary response samples. By their very nature, all are seriously flawed because we should not make conclusions about a population on the basis. On the basics of samples with a strong probability of bias. For example, the internet polls in which people online can decide whether to respond. That's correct, right? Because if you use the result from voluntary response sample and make the conclusion for the population, it is not like sometimes we have a bias, and bias if it's like kind of errors. If I mentioned that, so the error if it's large, it's not good, it's not correct for the for drawing the conclusion for the population. And for example, in this case, mail in polls in which people can decide whether to reply yes. Telephone call in polls in which newspaper, radio, or television announcements ask you to voluntarily call a special number to register your opinion. Yeah, we got a lot of scam calls every day, right? And those are like, that shouldn't be the samples, the right sample that we use for making the conclusion here. Any questions or comments so far, everyone? Is that too slow or too fast? Too slow. Okay, it's good. If you don't say anything, I'm gonna suppose that it's okay. Now let's do an example. The ABC television show Nightline asked viewers to call with their opinion about whether the United Nations headquarters should remain in the United States. Viewers then decided themselves whether to call with their opinions, and 67% of 186,000 people respondents said that the United Nations should be moved out of the United States. In a separate and independent survey, 500 respondents were randomly selected and surveyed, and 38% of this group wanted the United Nations to move out of the United States. So in this case, this is the voluntary response. Why? Can you please explain why do we have the voluntary response here?
Because they were able to call in and decided to give that information.
Mm-hmm. And in this case, if we use this result to decide to make the conclusion, then it's the wrong conclusion. Actually, the two polls produced dramatically different results. Look at this one. Mm-hmm. Yeah, so we can see in this case the bias, right, or the error is very big. And look at this one, 67%. This one like 38%.
But you only have a handful, it's like 500 versus 100.
Mm-hmm. Yes, totally agree. Mm-hmm. But the thing is, when they make the conclusion like, okay, the percentage, it means that's it. If we take like 67% of 186 and the other one is like 38% of 500 respondents.
So because during the TV show,
Mhm.
they're getting more people that are more like informed
Yeah.
about those issues,
Mm-hmm.
and it's targeting those people that are more vocal about it.
Yes.
Whereas an independent survey that's randomly selected people, it's just
Yeah.
using random people, so it's gonna give like better survey of the population because it's less biased information.
Mm-hmm. Yeah. So if we say like, because the two polls results are very different here, what do you think? Like, which one gonna give us like a better result? The smaller group or the larger group? Why?
Well,
Well,
if-
because a lot of the times, like, I work in marketing and nobody gives your opinion when they're happy. It's like going to a grocery store, you can have a 5-star grocery store, but realistically, like, people only give feedback when it's negative, like, oh, I had a horrible experience. So people that are probably watching Nightline are a very specified group of people.
Mm-hmm.
Like, I don't watch Nightline.
Mhm.
And it's probably a very like specific age group or different, like very specified,
Mm-hmm.
like cultures that watch that TV show. Whereas if you're randomly doing it, you can have a more diverse group, even though it's a smaller show.
Totally. Yeah. She has a point. What's your name?
Madison?
Madison, yeah, I agree with Madison that for the Nightline, for example, not like all the people we watch Nightline, and it's gonna be a specific class of like number of people watching that show, right? Moreover, the smaller group here, we can see randomly selected, was randomly selected, so it's gonna be better, right? When you see randomly selected, yeah, that's the main point. So in this case, the smaller group, even though they are smaller, but it's gonna give a better result because they are randomly selected. And
Biased opinion.
Chelsea,
Biased like for the 160.
yes,
86,000.
yes, I agree with you. Mm-hmm. Okay, so the next one, analyze. After completing our preparation by considering the context, source and sampling method, we begin analyze the data, correct, right? We are collecting data already, now analyzing it. How do we analyze the data? We need to graph and explore. And then after that, we need to apply the statistical methods to derive the conclusion. So for the graph and explore, an analysis should begin with appropriate graphs and exploration of the data. And for the statistical methods, there are a lot of methods we'll study later. A good statistical analysis does not require strong computational skills. A good statistical analysis does require using common sense and paying careful attention to sound statistical methods. Right? We don't need a very like big knife to kill maybe a small stuff. What is the animal? Mm, fly, right? To kill a small fly, but we need to use the common sense and paying careful attention to the statistical method. Have you heard about any statistical methods before? Which one? So my question is, have you heard about any statistical methods before? Some statistical method that you have heard? What do you think? Have you heard about Jesse?
Yeah, they're analyzing like the actual pieces or
Like for example, I think ratio, right? For what?
like the types of statistical methods,
Mhm.
like ratio, ordinal, nominal.
Actually, maybe you think about another terminology already, but I know you are trying to think about like some methods to analyze the data, right? I believe that you have heard about this one, but you may forget it. For example, when you study in around like 5th or 7th grade, like you have like the table of the data. Okay, A B C D E F, like those are the names of all the students, and they have some grade like 6, the 7, like from 1 to 10, right? And then they are asking, okay, let's find the average.
Like median.
Yes, median, yeah. And then so those are like some descriptive methods. Yeah, descriptive statistic method. And we also have some other inferential statistics method, like hypothesis testing. Have you heard about that one? Yeah, hypothesis testing, or we can find some confidence intervals, like within that intervals our result is like maybe 90%, we have 90% acceptance, something like that. I'm gonna record it later, so don't worry. This is just the introduction, right? So if you have not heard about that, it's fine, totally okay. That's why we are here, to study that. Regression analysis, right? Regression, maybe somebody who are studying data analysis or data science now, bachelor, right, in data science, you have heard of a lot about regression analysis. Yeah, linear regression, something like that. It's kind of like, for example, we have a lot of data, right, for the grade of all the students, and we need to find the line that separates the grade maybe greater than 5 and all the grade that's lower than 5, because if you got the grade lower than 5, you will be failed that class, and you will, if you get the other grades, you will pass, right? So we will find the line that separate like all the data to both sides. So it's gonna be like the linear regression. And the multivariate methods, or Bayesian statistics. Who have heard Bayesian statistics? Maybe in San Diego, specifically in San Diego, we have a lot of casinos around, right? Have you been in any casino here? So they do a lot of statistics about that. If, for example, if you go to a casino and the more you play, the more you lose, you never win. The the reason is there is a theory, there is a theorem about that. I can show you the textbook. It shows there's that theorem. So maybe if you want to relax, okay, you can go. But if you want to earn money or something, yeah, that's not the way.
Just go for the okay.
Or if you watch, there's a movie. There's a mathematics professor at a very like high-ranking university. I forgot, but this is real. He taught like actually I know there's a way to to calculate. Yeah, yeah. And then they have to remember that one divided into group, and it's based on a theory in statistics and probability as well. So that's some applications.
Yeah, I watched that movie.
Uh-huh. Yeah. And resampling methods as well. So there are a lot of methods. We will study it later on. Don't worry. And then the third step, we make the conclusion. The final step in our statistical process involves conclusion, and we should develop an ability to distinguish between statistical significance and practical significance. Right? We have this is statistical significance, and the other one. Okay, maybe let's have a break right here, and then we can come back after 5 minutes. Okay, let's relax a bit. Uh, we will get back to study those significance.
But you click on that and then you pop in the first couple of days and you'll be where you find that course material. But because this course doesn't have a thing before, this is why it's. So in the future, just know there's after you take this course and really get started, and then it'll be this course. Actually look into your lessons. Just what I'm more interested in, for each section for each.
Thank you. What chapter are you on now?
So we're at the end of chapter 1 section.
Yeah.
Yeah, so 17. I think what they're gonna do is, this is, they're talking about chapter 1. I said, when I started actually, this was like.
Yeah.
I didn't set anything, it took me like 3 classes to figure out.
I was in San Diego and they use one. That's.
Very different.
very.
Yeah, yeah, I was at
All these universities. use software. To your point, each class is.
yeah, I like to, American Military University. But, and I also. It did a lot, like, even navigating. Where to go.
Yeah.
Yeah. So once you go into it,
I didn't know
it's right here. This is
Well, I didn't know how to do these, so it was then the 8 week courses were.
Yeah.
Yeah.
Yeah, the 8 weeks were a little bit better, so I felt like it wasn't as condensed. But it was all online, and that was my, I don't really care for online schooling,
Yeah.
so the doing exactly what was kind of one of my options, especially when I was. I just used all the TA, so when I joined, I had almost 30 college credits right out of high school. And so I already had like half of my associates done, and then just finished on my social class after I had my GI, which was really nice, yeah.
What makes this good is that.
I mean, no, I went to go there.
Maybe we should check out the.
Yeah.
That's what I was doing now, and that had happened to me. It's like between, I go and they have.
Even if you pay for all your songs at the top.
Wasn't alive. I had instruments for it. I had a laptop and I was trying to do. And it just like very much a week ago. And I was talking to the counselor and I was like, hey, like I'm in the middle of the course right now. Like I need to get it on laptop now and today. And so I was. She just gave me a painter renders.
I'll be all right.
Yeah, like it's like.
The only thing is, I don't know if you would qualify because you are getting lectures. So if you have a degree.
Yeah.
It's in and
Oh,
about the job field.
Yeah, it's like.
Because the one of the programs was like. I know some people that do degrees.
No, that one's 48.
I know that.
48.
Yeah, both rehab, 48.
Is it 48?
Yeah.
Is that what you're using also?
I'll transition to both rehab in October.
It's a good deal. I've heard about it. I
You should.
haven't researched it.
Yeah. So what she mentioned, what did you say you got your degree in?
In the master's in supply chain.
Right, so what they do, they would interview you and basically look at your claims, right? Which is about the Navy, or whatever branch, right? And it has to be.
What client do you hear? Disability claims?
Yes, yeah, so that is something that I'll take to account. So like I got my degree in 19, so then I'll take a degree much older, so yeah, you can, you get up through the process. And it's like a full plan to like work you from like all the way up to whatever based on your conditions, right? Like I said, it's 48 months, and they want to look at like, hey, is the job field that you're in right now, what you're doing, is it conducive to, or some of your conditions that you filed, or, right? So they want to put you in the field, right? So that'll be better. So, yeah.
Like somebody has maybe disabilities, like, pretty severe, and you try to go into a trade field, like construction or. No. But I'm pursuing.
Guys, I know. Doesn't too much is about it. Like a big expression.
Check it out, I don't know if you qualify, but it's the shop is basically.
You say your benefits.
Yeah, 1 month to be able to qualify basically.
I use 18 months in a jail.
You should look at it before you, yeah, before you run out on your.
Say 1 month.
You know, that. And.
Yeah. Even if you just give it a bit, get those and see what you. Of them. Like, there's good thing about it.
Yeah, I think so, but I think I'm really gonna use it.
I'm the same, but I was. You can have. Over to math. Forty-eight, right?
Yeah. Like when.
I'm gonna be done with my master's with both my track. And you continue to go to school. We get your bachelor's.
So we already checked the yeah, you can continue to,
They transferred over, it's.
Just keep going.
yeah,
That's what I'm.
you can work on specifically that,
Because I asked you a question. And I was wondering, that I told me, I got my bachelor's.
So it's not very, obviously, you know, if you wanted something that's hybrid, right? It's not give you a full imaging, right? By someone that's something that's pulling them live. So, but yeah, you can, it's exhaust all of that.
Let's hope. Better in readiness. We have.
Mhm.
That, yeah, compared to horror stories about.
You gotta have at least
stuff
one.
that I skip. But I can put take those. Yeah.
Oh, I did.
So, yeah.
I did too, it's, I'm waiting for my line now.
So it did take, so that's what it's saying, like, just to like.
Yeah, yeah.
Right, you need to come up.
Yeah.
Sorry.
Yeah, I think I.
Okay.
So I'm.
Are we ready, everyone? Let's finish this one, okay? Okay, so let's get back to work and then we can have another break later. For the conclusion, as we discussed, we can use statistical significance or practical significance here, right? Let's see what is the definition of these two terminologies, and we will consider an example. The first thing, statistical significance. It is achieved in a study if the likelihood of an event occurring by chance is 5% or less. Getting 98 girls in 100 random births is statistically significant because such an extreme outcome is not likely to result from random chance, right? Getting 52 girls in 100 births is not statistically significant because that event could easily occur in random chance. Do you agree with that? Okay. So for practical significance, it is possible that some treatment or fighting is effective, but common sense might suggest that the treatment or fighting does not make enough of a difference to justify its use or to be practical. For example, like, so what is the difference between them? The statistical significance tells us the difference is unlikely due to chance, right? And the practical significance asks, does the, in this case, treatment of fighting is effective? Does not make enough of a difference to justify its use or to be practical.
That we, like the population and the sample.
No, for the population in sample, they are just like terminologies about the size, right? The size that we are taking the survey. Or the class of like, for example, the population is. Oh, I see what you mean. There's the size of agree with you. There's the size of the effect matter in reward terms. In this case, the answer is no. The training may not be practically worth it, even though the statistics says it had an effect. In this case, let me give you an example. I'm thinking about the example related to salary increase after training. For example, there is a story scenario like this. For example, in a company, we have after the training, we want to know if it improves employee salary, right? So the group A, for the average salary $60,000. The group B, we have maybe more than that. Let's say $61,000. And in this case, we have the same size. And then we will need to do some practical. We need to do some tests, like for example, the statistical test like t-test, or we calculate the p-value. We use the hypothesis testing, and then after that we get the result. Okay, the result is despite the statistical significance, the actual increase is only like 1,000, right? $1,000, because from $60,000 to $61,000, it is less than 1%. Let's say assume a less than 1% salary increase, and so it is. Is it the statistical significance, everyone? Less than, this is 5% or less. 5% or less. So this is 1%. Assume that it's less than that, right? So it is the statistical significance in this case. But is it practically significant? In this case, no, because why? In this case, it does not make enough of a difference to justify. Do we have enough result to justify it? Let's see. The employee wouldn't consider it it as a improvement because it's just like $1,000 per year, right? And the cost of the training may even like more than $1,000 because they have to do the training, for example. So in this case, we don't have enough evidence to make sure that it's the practical significance. Are we good, everyone? Because in the example, it doesn't give us enough information, so that's why we can conclude that. Now, let's consider this specific example about statistical significance versus practical significance. In a trial of weight loss programs, 21 subjects on the Atkins program lost an average of 2.1 kilograms or 4.6 pounds after 1 year, based on the data from that book or that journal, that paper. The results show that this loss is statistically significant and is not likely to occur by chance, right? Of course, in this case, like it is a disease, so that's why they wait. Yeah, because it is from the weight loss and heart disease reduction. So that's why it's not gonna occur by chance. However, many dieters believe that after following this diet for a year, a loss of only 2.1 kilograms is not worth the time, cost, and effort. So that for these people, this diet does not have practical significance. What do you think? So the number of participants, in this case, we have 21 participants, right? The result is, on average, they lost 2.1 kilograms after 1 year. And we all agree that this is it is statistically significant, because if we lost 2.1 kilograms after 1 year following this diet program, then it's unlikely to occur by chance. So the weight loss wasn't random or due to some yeah wasn't random, right? So we all agree that this is statistical significance. Are we good? But for practical significance, the amount of weight loss, just 2.1 kilograms over a full year, of course it will not matter much to most people, right? 2.1 pound, 2.1 kilograms. Yes.
So, for this example right here, so this folks looking for next, for, 5% chance, or less than a 5% chance.
Mhm.
Right, you got 21 subjects here, and it's an average of 2.1 kilograms, so we're really not talking about how much weight you're actually gonna use, it's an average, and so that average between 21 people could be a significant difference, so you don't really know what the average is, so is that really, statistically significant? But we don't really know what we're looking at.
Good question. Yeah, good question. But what do you want to say?
No, go ahead.
Yeah. So good question. In this case, I know what you want to say. In this case, when we say it is statistical significant, it is achieved in a study if the likelihood of an event occurring by chance is 5% or less. But it does. But in this case, it cannot even occur by chance, because in this case, it's gonna be in the diet program, right? They
It was, the same thing that makes it, practically, practically significant or whatever, not practically significant. Right, it's because of the time, so everybody's on this diet for 1 year, they only lose 4 pounds.
loss on average mean loss on average mean of 2.1 kilograms. So mean here, it means that we add all the, for example, the first person lost like 1 kilogram, the third person lost the 3 kilograms, we add them, divided it by 2, right? That's for 2 people, and in this case we do it for 21 people. And the result here, the thing is, the weight loss here wasn't random.
So statistical significance is the probability, like, there's a probability that it could occur, which is.
Firstly, it must occur firstly, it must satisfy the first thing here, like by chance first, and then after that we will like consider is 5% or less, right? But it didn't even satisfy the first part, like if the likelihood of an event occurring by chance is 5%.
Is based on the size of the effect.
That's a good question. So in this case, like it doesn't base, it's not based on 2.1 kilograms here, 2.1 kilograms, because 2.1 kilograms we cannot calculate the 5% or less here. It doesn't help us to find anything like 5% or less. How can you find that? Yeah, because we don't have.
Answer the question of the statistical significance. What the example.
I see what you mean. It is achieved in study, is a likelihood.
It's not less than 5%. So we can't tell what it is. It's a less than 5%, and how did it occur?
Yeah, I see what you mean.
It's usually 5%, right? Like in general. Or like to measure statistical significance, it's always usually 5% unless it's like a different study that goes to like 1%. Right?
So in this case, this event occurred by chance is 5% or less. For example, right? If you in this case, if you roll a dice, maybe one time you can calculate, okay, chance to get like 1 is 1/6, right? You get but in this case, like if you want to calculate that, 2.1. Okay, let's do that. Let's do that. At the beginning, I thought that we cannot calculate that, and then so that's why you have the question. If you cannot calculate that, how can you determine that's the statistical significance? So, but in this case, because in this example, they said that it is a statistical significance, right? Is that?
It has to met criteria of less than percent.
So that's why I'm trying to calculate it here. Let's see. Misleading conclusion. Sample data reported minimizing. This is not. They don't have any information, but they just mentioned like this result is statistically insignificant and is not likely to occur by chance. Is that not likely occur? Yes.
So I think the conclusion is,
No.
when we talk about 5% on the example that provide, we have a population,
Yes.
right?
Yes.
Like we have 500 people and they select maybe 100 people to do the survey. That might be like 5% of one thing, but I think the example they provide is different. The example they provide down here, like it's on the trial, it's like you do a survey, you wanna open a business, right? Or you wanna try a product. You select 21 people, that means
Yeah.
you will go. I think this is the wrong example for me. That's why.
Yeah.
Where's the population and you select these people to do the survey. But in this case, it's a random people they choose to do the stuff, so it's like there is no 5% down there.
Yes.
Yeah. I see.
Yeah.
Wait. I think I found the answer. Okay. That is not likely occur to that's not likely occur by chance, right? That means the event occurring by chance is 0%. 0%. Of course, it's less than 5%.
But how?
See.
Look, like that almost seems like a guess, right?
Yeah.
I know you're not guessing, because I can look at that and be like, all right, I can imagine that 21 people on a diet for a year are gonna lose some weight. 4 pounds is not a hard thing to lose in a year if you're on a diet, right? So statistically speaking, you'll probably lose 4 pounds
So-
if you diet.
So it's not by chance, it's on purpose. Here we are like on a diet program.
But so like, I think my question is with the 5%, because you can't calculate it, but also with that, right?
In this case, I know, maybe you finished that one.
But also with that, right, when we talk about having, because before you move down, you were talking about not having enough data, right? And then we start talking about this data we have here. That data, especially when you start using words like on average, right? And I guess I got it as the median, well, but you use average, so it's not actual data that we're using in order to get to that information. It's an average of, like I said, we got 21 people. I don't know how many people lost 10 pounds and how many people lost 2 pounds, but what we're expecting to get out of there. And how we came up with that number, and it's only 21 people.
So see, they are calculating in the number in this definition. It's gonna be like this. I'm gonna say the definition satisfies the example like this. So it's called statistical significance because it is achieved in a study if in this case, if the likelihood of this event occurring by chance is, in this case, this event occurring by chance is 0%. So that's why it satisfies that, because they mentioned it here. It's not likely to occur by chance because that is the result from this tunnel. I mean because we got the result from tunnel, and the results show that it is not likely to occur by chance. So when they say it is not likely to occur by chance, that means the event occur by chance is 0%. 0%, that is less than 5%. And yeah, they got the information from the tunnel. So that's why in this case they didn't have enough the time, no, because because when they write Juno, it contains a lot of information, and they just mention, okay, that is from the Juno. They cannot mention the whole thing, like from the Juno, and to show that is not likely occur by chance. But the sentence, it is not likely to occur by chance, is from the Juno. Yeah. So from that results from the Juno, it shows that this event occurred by chance is 0%, and this is less than 5%. So it satisfies the definition.
Okay.
Yeah. So we all agree with that, right? Okay, good. So let's consider the next thing: analyzing data, potential pitfalls, misleading conclusion. When forming a conclusion based on a statistical analysis, we should make statements that are clear even to those who have no understanding of statistics and its terminology. Yeah, I'm gonna show you. This is so the misleading conclusion was from the previous one, huh? Yes, same board. But now we understand the conclusion. But it is supposed to make everybody who doesn't know statistics understand that, right? Okay. Somehow it fails. Sample data reported instead of measured. When collecting data from people. Yeah. What was that, Josie?
I'm just thinking of like, I feel like it's jumping so far into that. I mean, like, it's talking about hypothesis, like testing right there.
Yeah, we have not.
Like,
Yeah. I mean, for the hypothesis testing, we will study it in the future.
Yeah, but it was like, you were just talking about it right there, but it's like a sneak peek of it.
Yeah, because they skipped, they just mentioned, okay, maybe just the abstract only, right? And then they moved to, yeah, because there are a lot of information from hypothesis testing. So
There's a lot of more information that we needed to understand.
yeah.
Yeah, it's going
Mm-hmm.
deep.
Yeah, we'll be fine in the end. If not, it's not the end. So we need to
We're not there yet.
reach.
Studying the definitions.
Yeah. When collecting data from people, it is better to take measurements yourself instead of asking subjects to report results. Yeah. So in this case, sample data reported instead of measured. That's not good, right? Loaded questions. If survey results are not worded carefully, the results of a study can be misleading. Agree. That was what happened earlier. Order of questions. Sometimes survey questions are unintentionally loaded by the order of the items being considered. Yes. And we have some other things. Non-response. Yeah, there are a lot of people like just giving you the survey. Okay, I'm sorry, I'm busy. So in this case, they refuse to respond or is unavailable. Low response rate. If a survey has a low response rate, the reliability of the results decreases. In addition to having a small sample size, there is an increased likelihood of having a bias among those who do respond. Yes, right? It's easy because, for example, I'm gonna do an evaluation and maybe just two of you submitted it. Like, okay, this professor is terrible or something. Then okay, can we believe that? Yes, because no, I'm just kidding. No, because we should like do the survey, like get more information from all the people. Percentages. Some studies cite misleading percentages. Know that 100% of some quantity is all of it. But if there are references made to percentages, that is it 100%. Such references are often not justified. What can be an example for this? What do you think?
An example of what?
But an example for the percentages, potential pitfalls.
Sorry, can you say it again?
Can you please give an example for the last case here? Like some studies cite misleading percentages.
Like, if a school had to take, a survey, but not everybody participated because some of them didn't want to respond to that particular survey. Like if it was students who, like, for example, are smoking under the age of 16, and now there's the school sending out letters to all the parents, and they are saying, I don't want to participate. Well, that's the wrong response, I guess.
In this case, like there are references make percentages that exist 100%.
So if all the students are there,
Yeah, and then for example, like 100 students, right? But we have like 102 something. We obtain
Survey back.
survey back. So that's
Oh, okay.
that's an example. But this one,
what is that?
yeah, it exists like 100% already, right?
Mhm.
Or what happened with the other two surveys?
It's like when
Weird.
Well, you can
Yes,
never have
survey.
102%.
Mm-hmm.
this one's talking about, if you have a survey and it says like 40% of people agree, 60% of people, don't agree, and then like 10% didn't respond. So like.
It's just like, that's not even, that's
Yeah.
about 100%.
Yeah, yeah. It's if that's the case, then how many? 110. How can it be 110? Oh, because like you compute like the 10 that does not respond, right? Mm-hmm. But if it does not respond, so it doesn't have any answer. I mean, it would not affect the result. I don't think that's gonna be the example for this one.
It's like you just can't go up 100%.
Mm-hmm.
Like there should be a study that says 110.
Because if like the other 10 we don't have any result there, we just remove them, like so we have 100% results back, right? So I think maybe if like one person do two surveys or something.
I think this slide's talking about references to.
Oh, references as well.
Really hard when it says like, 60% of people, 40%.
Mhm.
The number are adding up.
Yeah, and then maybe the oh, I see. Like for example, let's do like this: the 40 here and the city here, right? There are 10% in common, like 10% in common. They are mutual. They put the result for both. So maybe that can create the pitfalls. Okay, so let's move to the second section: types of data. Yeah, you have some questions. Oh, by the way, I just remember Chelsea name. What's your name, please?
DJ.
DJ. Yeah, DJ. Easy. Key concept. Know and understand the meanings of the term statistics and parameter. Describe different data types. The type of data is one of the key factors that determine the statistical methods used in the analysis of the data. Okay, let's find an example of parameter, a numerical measurements describing some characteristics of a population. So parameter goes with population, right? That's the numerical measurement. I'm going to give you an example later. And statistics, it is a numerical measurement describing some characteristic of a sample. So statistic goes with sample. Population goes with parameter, right? It starts with the P. This one starts with the S. That's the way to remember. Yes. Quantitative data. Quantitative or numerical data consists of numbers representing counts or measurements. So in this case, we have example, the weights of supermodels or the ages of respondents, right? They are quantitative or numerical data. This is easy. Categorical data or qualitative or attribute data consist of names or labels, not numbers that represent counts or measurements. because the number that represents count in the measurement, it's gonna be the quantitative data, right? In this case, qualitative, we have names or tables. Like the genders, male or female of professional athletics. Example, short numbers on professional athletics, uniform substitutes for names. That's easy, right? Very easy for those four terminologies. Working with quantitative data. Quantitative data can be further described by distinguishing between discrete and continuous types. Okay, maybe I'm gonna explain a little bit about discrete and continuous types. For example, for the continuous data, if I represent it as the graph, you can see it, all the data is going to be like continuously like this. If you do the discrete, maybe you can see like the data can be like, for example, 0, 0, 1, 0, 2, 3, -1, something like that. That's the discrete data, right? Discrete data result when the data values are quantitative and the number of values is finite or countable, like the number of tosses of a coin before getting tails. Oh, maybe we should do, let's do the example first, because if we keep doing like this, you cannot remember all the terminologies here. Let's see. So we know we just studied four terminologies, right? Statistical, it goes with sample, right? Parameter, population, and quantitative, qualitative data, four of them. Now we will move to in the quantitative, we separate it into two types of data. One is discrete, one is continuous. Are we good? So we have those types of data. So for the discrete type, the result when data values are quantitative and the number of values is finite, we did it. Continuous result from infinitely many possible quantitative values where the collection of values is not countable. The length of distances from 0 centimeters to 12 centimeters, right? So it's going to be continuous data. Levels of measurements. Another way of classifying data is to use four levels of measurements: nominal, ordinal, interval, and ratio. Let's consider four of them. But before moving to four of them, any questions so far? Qualitative data, we don't have anything like we didn't separate anything, right? But quantitative, we separate it into two types of data. One is discrete, one is continuous. The nominal level of measurements characterized by data that consist of names, labels, or categories only. The data cannot be arranged in some order, such as low to high. Example, survey responses of yes, no, or undecided. In this case, nominal level of measurement, because in this case, it belongs to categorize only, right? Yes, no, or undecided. Are we good? Yeah, I assume that is good. So that's why no questions. Ordinal level involves data that can be arranged in some order, but differences obtained by subtraction between data values either cannot be determined or are meaningless. So courses grades A, B, C, D, or F. A, B, C, D, or F. So in this case, we can arrange them in order, right? And in this case, differences between those great values either cannot be determined or are meaningless. Of course, because if you you find the difference between A and B, we cannot find the difference. Do you agree with that? So it satisfies the definition of ordinal level. Interval level. Interval level of measurement involves data that can be arranged in order, and the differences between data values can be found and are meaningful. However, there is no natural zero standing point at which none of the quantity is present. Years. Okay, we have 4 years here. In this case, it contains the data. We can arrange them in order, like from maybe small number to larger number, 1000, 1492, 1776, 2000, right? 1492. Okay. And what about other condition in the definition? The differences between data values can be found, of course, because we can find the difference between years. So in this case, it's called the interval level of measurement. So in this case, the interval level of measurements and the ordinal level, we have something in common and something different here. For the ordinal level, the data can be arranged as well, right? Ordinal and interval, they can be arranged. But for ordinal, we cannot find the difference between the data, right? And in interval level, we can find the difference between the data values. And in this case, nominal, let's say nominal is just like, okay, names, labels, and categories. Ratio level, okay, the name shows everything. Ratio level of measurement, data can be arranged in order. Differences can be found, of course, yes, and are meaningful. And there is a natural zero starting point where zero indicates that none of the quantity is present. Differences are ratio, and ratios are both meaningful. So in this case, class times of 50 minutes and 100 minutes, we can arrange them 50 minutes and then 100 minutes, right? And then we can find the difference between them, that is 50 minutes. And we can find the ratio, because like it's just like 5/10 or 1/2 in this case. And it's most meaningful because when you find the difference between the class, let's use class time A and class time B. In this case, we know like which class has a longer time, meeting time, and the other one is shorter meeting time. And the ratio shows that, okay, maybe one class is like the meeting time of the first class is double than that of the second class, right? Do you agree with me? So that's why it's called the ratio level.
The interval one has
So-
no zero. It cannot start from zero, I think.
Oh, yeah, and there is a natural zero starting point.
Because yours cannot say zero.
Let's see. In this case, there is no natural zero starting point because why? None of the quantity is present, because in this case, years zero. We don't have that. That doesn't make any sense. But in this case, we have the class time of 0 minutes. That means like, okay, we have no class at all, right? So it makes sense in this case, and zero natural zero is meaningful in this case. Are we good? Yeah. So that's the differences between levels of measurements. Here we have the summary. This is 4 of them. Are we good, everyone? Okay, so far so good. Then maybe before moving to this section, we can have a quick break, maybe 5 minutes, and then we can continue. Okay. Meanwhile, if you have any questions, you can please feel free to ask me. you like, or you are living near you, or how long you drive to the day? An hour, really? From many feet, where is that, up north? Wow, like more, like longer than 10 kilometers, further. Further. Oh my God. So that's like at a mountain area.
What's that?
Further.
I would say mountain area.
Oh, I see.
I mean, there's a couple of hills over there.
But it's good that we just need to come here 2 times a month.
Yeah.
Other times like we can do
I
one.
don't mind coming down today, well,
Honestly.
I live in Timber.
Oh, so like 45 minutes away from here. 45.
An hour, 45 minutes.
I would, by
that's if
SSU,
she do a speed.
Right.
SCSU,
I see you. Oh, you're going on.
live in Rolando, Park.
Because I'm currently teaching, but I work full time in SBSU. Yeah.
I live about 2 people walk away to the,
Oh,
near the routes and sort of,
yeah. What is it?
next one.
April 29th.
105, is it?
I live by the routes, it's down, at the other end of Montezuma Boulevard. there.
Oh, thanks. Yeah. That's close. So what do you?
No. Oh, good. Well, I take a lot of classes, but like I was saying earlier, like I was hitting back when I was in Marine. And after I got out, like not the same in physical shape, like just made everything get worse.
Yeah. Sit here. Normally, like I just teach like graduate students, SDSU, like doctoral students. I teach like 3 hours a week. And mostly like I just gave them papers and they read and present like some research. Yeah.
What did you say again? What did you do?
My degree, yeah, I got a doctoral degree in applied mathematics, optimization and optimal control. So my research, I graduated in 2016. So at that time, I did something like related to optimal control most of the time. For example, you want to minimize the distance from the school to the house, right? And you want to find the shortest path. You want to avoid all other cars. You want to save energy, save gas. That's the optimization problem that I did. Yeah, and then you have to minimize, okay, the speed of the car to make sure that you don't waste a lot of gas, right? Or you there are a lot of applications in economics. For example, we maximize the profit of the company, minimize the risk, or organizing the stuff inside the truck or something to make sure that we earn a lot of profit. Or in I did some application in medical school as well. And like my collaborator worked at Stanford University, so I visited him to do some project like minimizing the beam delivery time to detect the tumor in brain cancer. For example, if you can find the minimum time, then you can detect that faster, and then they can do that for the MRI machine. Yeah. And also like for nanoparticles model or marine surface vehicle models, the marine vehicle model as well. So same idea. You want to find the shortest distance from A to B, and the marines can like go very like find the shortest path to the target, and they will avoid all other obstacles on the way as well. So it has a lot of applications, and we apply for some fundings from Navy also, like from NSF or something like that. But like during this time, it's kind of hard for the funding. Yeah. Yeah, my main work is just like doing research and like in writing papers, writing books. I'm writing a book related to machine learning. Yeah, I wrote like maybe around right now it's about like 100 pages already. I try to polish it, and I'm trying to polish it and to see if I can like publish it. Yeah, it takes time. But I can share it with you if you want. I'll share it as the gift. Like, if you like it.
No. I agree. Sports psychology.
Oh.
Yeah.
Sociology.
My first degree, in entrepreneurship. Yeah. This? Yeah.
Yeah.
I'm trying to take a different path, you know what I'm saying?
Tell you all the time, the best thing you can have in life is options, when you got some options.
Right. Yeah.
That's the best thing I tell all, that's the best thing you can have in life. Love, money. Get some options.
I work full time, so, yeah. Big flex.
You said you do work full time?
I work full time also.
Full time for woman for
Contract support.
contract support.
EBR.
What is that? Ethereum.
So it's located right here in Mission Valley.
I know.
So basically, keep it simple. I procure communications on the sea. A bunch of secret stuff.
The job you do right now, or the breaking business, everyone you rap?
No,
Oh,
not at all.
totally different.
Totally different. I'm both men. Completely opposite. Yeah, I'm pretty sure, like, if I look at that board, pretty sure like I'm a meaningful.
Was it like finding that job falling into?
It's all about everybody take me. Get out, it's all about who you know. That's how you know when your job network.
Yeah.
It's not gonna be like, oh, yeah, you know, that percentage is gonna be slim. Yeah. Like I did my retirement ceremony in July, like a substitute teacher at my kids' school. And right after that, I had a partner who was at my wedding back in 2009. So it was like, hey, give me a resume. And like, before I know it. Yeah.
I'd say LinkedIn too. Yeah. I got found on LinkedIn and I work for the best company. I work remote from home. Company's located in San Francisco. Not micromanaged. The company truck, company expense account, don't pay for gas. They're like, just go on the military base, go talk to Swarmit, go, to NASCO, BAE Systems, PCE. These are the ones that do the ship repair. Right? And it's just like, I'm down here by myself. They're in San Francisco. We got reps in Norfolk and Seattle. They found me on LinkedIn. I mean, I didn't know anybody in San Diego. We're just looking for a veteran that can get on base. I was like, well, I gotta, by the time I was in the reserves, so I got an active duty cat card. And dude, I mean, I have, in my opinion, the best job. Half the day when my chairman's working at home, not being micromanaged. I get to, then I get to go to Hawaii. It's, I got a real, I lucked out, but I think LinkedIn and, your profile set up there, it's huge.
Yeah, you get the.
Combat systems jobs, it depends on what you do. That's what I went on to when I first became a contractor.
LinkedIn,
I just went on to, I just was like was still active duty, but I went into combat systems. That was just posted like what I did in the military, brief thing, blah, 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 blah. It was like a lot of different people reaching out, yeah. It just depends. I was really lucky because I was at a training command, so it's a little different.
yeah,
But everybody's situation is different.
everywhere, right?
Yeah.
See, like Career Builder or Monster or stuff like that is all scams. For whatever reason, LinkedIn's a little bit more authentic.
It's
You still
starting to come
get-
around that way.
There's a
though.
lot of people who, like, I know in the military that, like, utilize LinkedIn and then
Yeah.
they've gotten plenty of hits.
Recruiters will find you on LinkedIn.
Recruiters and
Yeah.
Obasi used to put on stuff on LinkedIn and always trying to.
My buddy's a recruiter for Amazon. He's like, he makes, I mean, it's corporate Amazon, it's not the truck drivers. But I mean, they're always looking, he's always looking at, bring people on, pick the corporate side, not the actual like delivery drivers. That's here in Mission Valley also. Give you his number if you want it. You live in Midfield, so that's a high thing in Mission Valley every day.
What was your job?
Right?
Yeah, we gotta make.
Yeah.
I got,
DAT right now,
I got,
DAT.
yeah, I got a bunch of forums, I mean, I do a lot of stuff, so a lot of different stuff. It's not just gun play stuff, but you know, like right now, I'm on the Army team, behavioral assistant business, I work for ACES, but you know, that's not full-time employment or anything like that.
Have you looked on the car systems thing?
I actually just started looking at, so I am on LinkedIn, and I was looking at,
That Facebook page? You know, who knows? Car systems jobs.
I think I was, for a second, I was just trying to figure out if I actually want to. I don't know what the military. That was.
That's how I want us to. I was like, I want to steer clear.
I mean, quite after that, it's like. Stress level on 1 million, you know what I'm saying? I'm trying to learn how to relax again. You know, they say once you retire, you die, you don't have all that stress. You're so used to it. I want to be stressed.
Stress is what runs there.
Yeah.
Yeah, like she said earlier, we could have a situation, on the company side, you know, it's gonna be significantly higher versus on the better side. But it's a lot more about.
Yeah, and then you'll see my. You want to ask about what I posted? Okay. I think you see the coach. But.
You get a job now, and then you start to.
Whatever she did, but I'll watch it. Whatever, but. I think the base is there.
Yeah.
Oh.
Okay, so let's get back to work, huh? We can do it in 30 more minutes and then done. Yeah. So are we ready? So let's get started with big data. Big data refers to data sets so large and so complex that their analysis is beyond and capabilities of traditional software tools. Analysis of big data may require softwares simultaneously running in parallels on many different computers. For example, can you give me an example of big data in real life applications? Any women can give this example. What about like past purchases? Big data. It refers to large and so complex analysis, right? Data, because you have a lot of like if you compute like all the things, you collect all the data from the past purchases. It's gonna be like big data, or shopping cart activities, or yes, votes, reviews and ratings, right? or
Image analysis.
or the time spending on social media, or time spending on watching TV. No, not that. Oh, yes, right. Big data, right? Yeah. Data from million users from like everywhere around the world. Data science involves applications of statistics, computer science, and software engineering, along with some other relevant fields such as sociology or finance. So, what can be an example for data science? Data science actually like machine learning, deep reinforcement learning, uh, clustering and classifications, or like we have what can be maybe for specifically if you talk about machine learning, right? In data science, you can find some example. For example, if we take the photo and the photo is blurry, right? So you want to make sure that that photo is going to be clear. And then what should we do? We do some filtering stuff, or we put it through maybe some software, and we can like make the photo like more clear, right? Clearer. So that's an application in data science, or like a lot of application that I just talked to the Jay earlier, right? About optimization, because optimization is also like data science, because data science is one part of optimization. And some application that I mentioned earlier, that is also belong to data science. And say it louder, please.
Like earnings.
Accounting, earning, yeah, profit, right? Maximizing profit, yes, that is also data science. Or or we can consider another thing in data science, like algorithms and models.
Like market indicators, like I was saying, like the stock market.
Correct. Yes, prediction. Yeah, we do it every. We see it every day, right? This I think, yeah, if you look at Tesla stock, it's going down now. And if you, yeah, if you, so that is also like an applications of data science, because we are using some tools in optimization in data science to predict the result. Have you heard about neural network? Yeah, a neural network. We have like the input layer, the output layer, and the hidden layer. So when you have the input layer, your output you can predict, the output. So that's what they use it for finance, right? So who just told me you did finance, right? Yeah, I forgot the name. What's the name of the Coco? Coco, yeah, you did finance. So I think that's gonna be a very good application for you to do in the future, or transportation or healthcare as well. Okay, so for the missing data, a data value is missing completely at random if the likelihood of its being missing is independent of its value or any of the other values in the data set. That is, any data value is just as likely to be missing as any other data value. A data value is missing not at random if the missing value is related to the reason that is missing. It's easy, right? Easy to understand. Okay, so maybe do you want to find some examples, two examples for these two? The first one, missing completely at random. Random, and the second one, missing not at random. Missing at random.
So we're talking about like trying to manipulate the data, like. If it's missing because we didn't ask for that question as opposed to. Or missing because that's not part of the question as opposed to intentionally. leaving it out.
I see. Yeah. So one of them is like we did it because we make mistakes in the calculation and we missed like some equations and we missed data.
So
But
missing
that
is
is like
random.
that is random, right?
So.
But if they intentionally like maybe they make mistakes or they didn't intentionally do that, so that's not that's at random, right? And the other one not at random.
It's an omission, right?
How?
It's not at random, it's missing, but it's not at random, so it's an intentional omission. That,
Not at random, the intentional missing. Okay.
it's not omitting data, and you don't.
Mhm.
The second one is not intentional. That might be something happened, and I don't know if something happened that
Mm.
could be the reason why you don't always miss.
Yeah, no.
But that would be the first one, right? Because the second one is missing, is not.
Yeah, I totally agree with your first one. Yeah. I think everybody agree with your first example too. And your second example, I'm still like, not at random because they intentionally did that.
Keep our information intentionally, it's omitting.
Mm.
That's correct, right? No?
Yeah. I think
Right to me.
they sounds right too. Brian has any other examples? Like for example, when
If you leave out data intentionally, you are omitting something. About as clear as it gets.
like for example, you are doing the survey, like collecting the data for maybe for the monthly income. Some people they intentionally like they don't want to release their like of course their information, right? Because so the privacy. So that is like missing, not at random. Agree with that? Because they did that on purpose. Do you agree with me?
I don't know.
What is the last part
So-
related to the reason that it is missing?
So the thing is, like my example is, you are collecting data on monthly income, and some people with maybe some people choose not to respond to that question. So in this case, the reason of the data is missing is related to the people who did that on purpose. They didn't want to release the information, so that is not at random, right? Of course, like that it's not happening. Really.
Intentional active omission.
Say that again, please. Not active on omission.
So the reason that it's missing is privacy.
Yeah. So that's not at random too.
If there's 100 people and 80 or 20 say we're just gonna omit, we're just gonna not put anything, now our data is out of 80, not out of 100.
80 out of 100. Yeah. So we are missing 20, right? Yeah.
We're not missing those 20 are not included, because they didn't. So I would say, like, if we're gonna use the same example of collecting, wage data, right?
Mm-hmm.
So I'm going to a job and the data says that, everybody here, or out of 100 people, right? They make, they make $10,000 a month, right?
Mm-hmm.
Right? The omission would be that they work massive overtime.
Mm-hmm.
Right? So that data being left out would be important for the statistic, right? So,
Mm-hmm.
so me knowing that it's not out of a normal 40-hour week,
Mm-hmm.
it's really out of a 60-hour week. They work a 60-hour week,
Mhm.
right? Not putting 60 hours in there and just saying they make $10,000 a month makes me assume that working a normal job schedule is there to make me assume something.
Mm-hmm.
And that is missing, not at random. They intend.
Yeah, I mean-
say 60 hours.
Yes, I mean that is a specific example, and I agree with that as well. It's also like my example is similar to that one, but it's just like not very specific. It's general. Yeah, the intentional. Yes, correct, yeah.
It just randomly happens.
Correct, yes. So we all agree with that, right? We are good with that, right? Any, okay. Correcting or missing data. Delete cases. One very common method for dealing with missing data is to delete all subjects having any missing values. Like we remove all those people from the samples. So the sample may be smaller, but it's going to be more accurate. Agree? Because like those people, they didn't want to release the data. If we add them to that sample or that population, it's gonna make the result like less accurate.
But does it put on the study?
Yes.
Like, does it put on the study?
For example,
You have deleted cases, but it's like a biased study. Would that make it more-
I agree with you. Yeah, when we have the bias study, right? Then if the bias study, we can do other methods to make sure it's more accurate. Here we are just talking about the missing data. The missing data may cause bias. Yeah, I agree with you because sometimes like if we miss that data, right, then it's gonna cause the error. So in that case, we remove those people who didn't put the results in the survey, and we remove like completely those people out of the table because of their data they are missing. So remove them. Now the size of the population or the sample is smaller, but everybody put their results there, and we're gonna get a better conclusion. Do you agree with that, Jesse?
Yeah.
Input, sorry. Oh, wait. Typo. Input missing values. We input, yeah. Missing data values when we substitute values for them. We input, sorry, I think this slide has something that I need to correct. So in this case, agree, right? If you find like some missing data on the table, maybe some of you in the class, I'm gonna do the evaluation, and some of you didn't do the evaluation. So I'm gonna just like like distribute the evaluation form again to those people, and they fill in the information, and I collected it. So it's gonna be fine, and we have the good conclusion. Okay, so those are two ways to correct the missing data. Now, we are going to study the collecting sample data. Yeah, Maury? No? When analyzing sample data, it is essential to use an appropriate method for collecting those sample data. Of particular importance is the simple random sample. If sample data are not collected in an appropriate way, the data may be so utterly useless that no amount of statistical torturing can salvage them. Let's see an example for this. Simple random sample. Let's see. Okay, so let's find an example of particular importance. Simple random sample. We know random sample already. In this case, simple. What can be what can be an example in this case? What do you think? Sample data are not collected in an appropriate way. The data may be so utterly useless.
Somebody, you either read.
Force,
Somebody.
like, for example, for example, the survey can be obtained by like forcing people to put that results there, or maybe like, I'm not saying it should I? Like for example, when you you obtain some like in some companies, right? Some people want to do the survey, but they want to have like maybe benefits for them, so they like kind of do some some tricks and get the good results for themselves. So that's not gonna be the appropriate way to collect the data, and those data like will be so utterly useless that no amount of statistical totally can salvage them, right? That is like one of the example for the this key concept. The gold standard randomness with placebo treatment groups is sometimes called gold standard because it is so effective. A placebo is harmless and ineffective pill, medicine, or procedure sometimes used for psychological benefit or sometimes used by researcher for comparison to other treatments. A placebo such as a sugar pill has no medicinal effect. Can you please give me an example for this terminology, gold standard? What do you think?
Maybe like, they're measuring. Like a systolic. Hypertension, blood pressure medication, then they have like treatment A, treatment B, and then a placebo.
Mm-hmm. Harmless and ineffective
Yeah.
pill.
So, they're just trying to measure what. If it's actually curing hypertension or.
Maybe.
Yeah, so like a placebo effect, but of course, it's if you're just taking the pill
For like some disease, mental illness, something like that. Huh?
and it's not actually anything, it's just a sugar pill, but.
Yeah, you are supposed to be a dentist. Yeah, you should study some medicine, maybe medical school as well. That's I think that's maybe we can yeah, I think do you agree with Chelsea's answer, everyone? I think it is acceptable here in this case. I agree. Basics of collecting data. Statistical methods are driven by the data that we collect. We typically obtain data from two distinct sources: observational studies and experiments. Yes, right. We observe everything, we study that one, or we do experiments. So those are two things to collect data. For experiment, apply some treatment and then proceed to observe its effects on the individuals. The individuals in experiments are called experimental units, and they are often called subjects when they are people. Yeah, we usually see that when we do treatment, some experiments, right? And people we just call like some objects. If you do it the experiments with animals, then no, they will not call them. They will just animals. They will still call subjects, right? It's just some stuff, other stuff they will call objects. And observational study observe and measure specific characteristics without attempting to modify the individuals being studied. That's easy. Example. We still have 5 minutes, right? We can do these two examples. Observational study. Observe past data to conclude that ice cream causes drownings based on data showing that increases in ice cream sales are associated with increases in drownings. The mistake is to miss the lurking variable of temperature and the failure to see that as the temperature increases, ice cream sales increases and drownings increase because more people swim. What observational more drowning because more people study, more people swim. They should have like okay, more people running because like they don't know how to swim or something like.
No, it's really a good example. It talks about how we get a lot of statistics out right now. So somebody can look at that. They can put all the data that says that hey, if these ice cream sales are going up, the data will look conclusive, right? Because it looks like that
the sale of ice creams are related to the drowning. It's not relational, it's causational, right?
It's
So causation. is what's happening.
Yeah. I agree with you, but the thing is, like,
Correlation.
correlation.
Causation, yeah.
Yeah.
That's what that is. So it correlates because it's happening at the same time. And so you can make a statistical, you can make a graph and show that these things are happening, and you can make it look like it's right because these are facts.
Yeah.
More ice cream was sold, more drownings happen, right? And they can say that it happened because of that if you're looking at the data incorrectly, or if somebody's manipulating the data to make you look at it. So understanding that even when you look at that data, knowing that people are not dying because they're eating ice cream. They're dying because they're drowning because it's hot outside, and it's hot outside is while they're eating ice cream, it's also while they're swimming. So both of these things
So
happen.
in this thing, it's like because of the variable is the temperature. Like the x-axis can be the temperature. The y-axis, like we can have like two curves. One curve is gonna be for the ice cream sales, and the other curve is gonna be the number of the people like drowning, and then like it's gonna go up like that. But in this case, actually, you make it like more accurate. Like it should have more factors and like more variables there, right? Okay, but this is an example for observational study. Agree with that? Yeah. Thank you, DJ. Now the ice cream and drowning experiments. Conduct an experiment with one group treated with ice cream while another group gets no ice cream. We would see that the rate of drowning victims is about the same in both groups. So ice cream consumption has no effect on drownings. Yeah. Here the experiment is clearly better than the observational study, right?
I think the issue is they're eating the ice cream while they're drowning.
Okay, so sometimes we have to make a lot of experiment. We observe things and then we have to test it again, right? We shouldn't just like okay believe in what we observe. That's the key here. We should do a lot of experiments, not just one as well. Okay, thank you everyone. Yeah. Do you need an ice cream? Okay.